Reliability tells you how consistently a method measures something. When you apply the same method to the same sample under the same conditions, you should get the same results. If not, the method of measurement may be unreliable. There are four main types of reliability. Each can be estimated by comparing different sets of results produced by the same method. We have the test-retest reliability, in which it measures the consistency of the same test over time. The inter-rater reliability, it measures the consistency of the same test conducted by different people. The parallel forms, which measures the consistency of different versions of a test which are designed to be equivalent, and the internal consistency, which measures the consistency of the individual items of a test. Test-retest reliability measures the consistency of results when you repeat the same test on the same sample at different point in time. You use it when you are measuring something that you expect to stay constant in your sample. So why is this important? Many factors can influence your results at different points in time. For example, respondents might experience different moods, or external conditions might affect their ability to respond accurately. So test-retest reliability can be used to assess how well a method resists these particular factors over time. So the smaller the difference between the two sets of results, the higher the test-retest reliability. So how do we measure test-retest reliability? So to measure test-retest reliability, you conduct the same test on the same group of people at two different points in time. Then after that, you calculate the correlation between the two sets of results. Another example is when you devise a questionnaire to measure IQ of a group of participants. Then you administer the test 2 months apart to the same group of people. But when you found that the results are significantly different, so you can interpret that the test-retest reliability of the IQ questionnaire is somewhat low. The next type is inter-rater reliability. Inter-rater reliability measures the degree of agreement between the different people observing or assessing the same thing. So you use it when data is collected by researchers assigning ratings, scores, or categories to one or more variables. So why is this important? People are subjective, so different observers' perceptions of situations and phenomena naturally differ. Reliable research aims to minimize subjectivity as much as possible so that a different researcher could replicate the same results. When designing the scale and criteria for data collection, it's important to make sure that different people will rate the same variable consistently with minimal bias. This is especially important when there are multiple researchers involved in data collection or analysis. So how do we measure it? So to measure inter-rater reliability, different researchers conduct the same measurement or observation on the same sample. Then you calculate the correlation between their different sets of results. If all the researchers give similar ratings, the test has high inter-rater reliability. Another type is parallel forms reliability. Parallel forms reliability measures the correlation between two equivalent versions of a test. You use it when you have two different assessment tools or sets of questions designed to measure the same thing. So why is this important? If you want to use multiple different versions of a test, for example, to avoid respondents repeating the same answer from memory, you first need to make sure that all the sets of questions or measurements give reliable results. For example, in educational assessment, it is often necessary to create different versions of tests to ensure that students don't have access to the questions in advance. Parallel forms reliability means that if the same students take two different versions of a reading comprehension test, they should get similar results in both tests. How to measure it? The most common way to measure parallel forms reliability is to produce a large set of questions to evaluate the same thing, then divide these randomly into two question sets. The same group of respondents answers both sets, and you calculate the correlation between the results. High correlation between two indicates high parallel forms reliability. The last type is internal consistency. Internal consistency assesses the correlation between multiple items in a test that are intended to measure the same construct. You can calculate internal consistency without repeating the test or involving other researchers. So it's a good way of assessing reliability when you only have one data set. So why is this important? When you devise a set of questions or ratings that will be combined into an overall score, you have to make sure that all of the items really do reflect the same thing. If responses to different items contradict one another, then the test might be unreliable. This is actually very common in research. So for example, if you want to measure student satisfaction with the school services, you create a questionnaire with a set of statements that respondent must or the respondents must agree or disagree with. So internal consistency tells you whether the statements are all reliable indicators of students' satisfaction. So usually in internal consistency, we utilize the Cronbach's alpha value. It should be above 0.70. If the Cronbach's alpha value is above 0.70, then that would mean that your questionnaire is reliable. To make a specific measurement, there are actually two common methods. The first is average inter-item correlation. So for a set of measures designed to assess the same construct, you calculate the correlation between the results of all possible pairs of items and then calculate the average. Another method is split half reliability. So in this case, you randomly split a set of measures into two sets. After testing the entire set on the respondents, you calculate the correlation between the two sets of responses. Now let's move on to another lecture which will be all about validity. By the time we're done, you'll be able to differentiate between reliability and validity. Validity refers to the accuracy of inferences drawn from an assessment. It is the degree to which the assessment measures what it is intended to measure. So for example, if your true weight is 180 pounds and the scale reported that your weight is 180 pounds, then that is a valid measure of your weight. So why validity is necessary? While reliability is necessary, it alone is not sufficient. For a test to be reliable, it also needs to be valid. For example, if your scale is off by 5 pounds, it reads your weight every day with an excess 5 pounds. The scale is reliable because it consistently reports the same weight every day, but it is not valid because it adds additional 5 pounds to your true weight. It is not a valid measure of your weight. There are many types of validity that include construct validity, content validity, phase validity, and criterion validity. Construct validity is about how well a test measures the concept it was designed to evaluate. It's very crucial to establishing the overall validity of a method. Thus, assessing construct validity is especially important when you're researching something that can't be measured or observed directly, such as, for example, intelligence, self-confidence, or happiness. You need multiple observable or measurable indicators or dimensions to measure those constructs. So what is a construct? A construct is a theoretical concept, theme, or idea based on empirical observations. It also called it is also called as a variable that's usually not directly measurable. For example, psychologists develop a research construct to understand individual and group differences, such as commitment. So, organizational commitment has three dimensions. We have the affective commitment, normative commitment, and continuance commitment. So these affective, normative, and continuance commitment, these are called as indicators or dimensions of organizational commitment. So organizational commitment cannot be directly measured, but it can be directly observed through these three constructs: affective, normative, and continuance. So in research, it's important to operationalize constructs into concrete and measurable characteristics based on your idea of the construct and its dimensions. Construct validity also have two main types. We have the convergent validity, in which it measures the extent to which your measure correspond to measures of related constructs. And we have also the discriminant validity. It is the extent to which your measure is unrelated or negatively related to measures of distinct constructs. In convergent validity, like for example in research studies, you expect measures of related constructs to correlate with one another. If you have two related scales or measurements, people who score highly on one scale tend to score highly on other scale as well. On the other hand, the discriminant validity means that the two measures of unrelated constructs that should be unrelated, very weakly related, or negatively related actually, are in practice. So just like the convergent validity, you check for discriminant validity by comparing results for different measures and assessing whether or how they correlate. So how do you select unrelated constructs? It's good to pick constructs that are theoretically distinct or opposing concepts within the same category. For example, if your construct of interest is a personality trait, like for example, introversion, it's appropriate to pick a completely opposing personality trait, example, extroversion, which is the opposite. So with that, you can expect results for your introversion test to be negatively correlated with results for a measure of extroversion. The next type is content validity. Content validity assesses whether a test is representative of all aspects of the construct. So to produce valid results, the content of a test, survey, or measurement method must cover all relevant parts of the subject it aims to measure. If some aspects are missing from the measurement, or if irrelevant aspects are included, the validity is threatened. So for example, a mathematics teacher developed an end-of-semester algebra test for her class. The test should cover every form of algebra that was taught in the class. If some types of algebra are left out, then the results may not be an accurate indication of students' understanding of the subject. Similarly, if she includes questions that are not related to algebra, the results are no longer a valid measure of algebra knowledge. So that is why in content validity, you have to consider whether the items of the questionnaire really measure the construct that you wanted to measure. Meanwhile, when we talk about face validity, it considers how suitable the content of a test seems to be on the surface. It's similar to content validity, but face validity is a more informal and subjective assessment. So for example, you create a survey to measure the regularity of people's dietary habits. You review the survey items, which ask questions about every meal of the day and snacks eaten in between for every day of the week. On its surface, the survey seemed like a good representation of what you want to test, so you consider it to have a high face validity. So, since face validity is a subjective measure, it's often considered the weakest form of validity. However, it can be useful in the initial stages of developing a method. The next type is criterion validity. Criterion validity evaluates how well a test can predict a concrete outcome, or how well the results of your test approximate the results of another test. So what is a criterion variable? A criterion variable is an established and effective measurement that is widely considered valid, sometimes referred to as a gold standard measurement. So to evaluate criterion validity, you calculate the correlation between the results of your measurement and the results of the criterion measurement. If there is a high correlation, this gives a good indication that your test is measuring what it intends to measure. So for example, a university professor creates a new test to measure applicants' English writing ability. To assess how well the test really does measures students' writing ability, she finds an existing test that is considered a valid measurement of English writing ability and compares the results when the same group of students take both tests. If the outcomes are very similar, the new test has high criterion validity. Another example is a job applicant takes a performance test during the interview process. If this test accurately predicts how well the employee will perform on the job, then the test is said to have a criterion validity. So always remember that criterion validity measures how well one measure predicts an outcome for another measure. So in the example, the first measure, like for example, the job performance test, is sometimes called the predictor variable or the estimator. The second measure is called as the criterion variable, as long as the measure is known to be valid tool for predicting outcomes. So there are also types of criterion validity. First is the predictive validity. If the test accurately predicts what it is supposed to predict, for example, the NAT examination predictive exhibits predictive validity for performance in college. It can also refer to when scores from the predictor measures are taken first and then the criterion data is collected later. That is why in high school there is a national aptitude test. Since that particular NAT scores are believed to be a predictor for the performance of these students when they go to college. Another type is concurrent validity, when the predictor and criterion data are collected at the same time. It can also refer to when a test replaces another test because of course it is cheaper. So for example, a written driver's test replaces an in-person test with an instructor in driving. Again, as a review, there are four main types of validity. We have construct validity. Does the test measure the concept that it's intended to measure? We have the content validity. Is the test fully representative of what it aims to measure? We have the phase validity. Does the content of the test appear to be suitable to its aims? And we have also the criterion validity. Do the results accurately measure the concrete outcome they are designed to measure? So what are some ways to improve validity? First, you have to make sure your goals and objectives are clearly defined and operationalized. Expectations of students should be written down. Second, match your assessment measure to your goals and objectives. Additionally, have the test reviewed by faculty at other schools to obtain feedback from an outside party who is less invested in the instrument. Third, get students involved. Have the students look over the assessment for troublesome wording or other difficulties. And the last, if possible, compare your measure with other measures or data that may be available.